Okay, 2015. Now in this case, right, B, it shoots off the speed 8 meters per second, but not perpendicular. Right, this is important. This is a different one to the last one. At an angle of 60 degrees. Okay, where the distance between A and B is L, right? So if we think of A starting here, right, and of course then that distance L, right, is say there. Okay, so we've got L there, right? Now B shoots off in this direction, isn't it, of 60 degrees. Okay. Right, so maybe we'll put 60 degrees in there, which will help. Okay, and of course it takes the string with it until it gets to a point when it's taut. Okay, so the string, of course, B's up here now, and it's connected to A, and of course it's going to get taut, right? Because here it's all loose, isn't it? It's all loose in this situation here, joining A to B at the start. Yeah, it's all loose, but then when it shoots off in this direction, okay, and B ends up over here, then this then is going to be taut, and this is going to be 3L, of course. Okay, so B is going to be here then, just at the point of being taut. Okay, now we need to, of course, remember we've got to resolve along the string, because this here at the start, of course, is going 8, isn't it, in that direction. Okay, that angle they gave, but we need to resolve along this string, isn't it? Along the string that joins A to B, right? So we need to have a resolution along that string there, and of course perpendicular to it. Okay, now in order for that we need this angle maybe here, okay, and this angle called theta corresponds to this angle, theta here. Now it's not a right angle triangle, so you can't use SOHCAHTOA, but we know that's 120 there because it's a straight line. But it looks like we're going to have to use the sine rule. Okay, so remember the sine rule. We can use it because we've got a pair. We've got an angle here and we know the opposite side. It's the sine rule. That's what we want, isn't it? It's the sine theta over L equals sine 120, one we know, over 3L. Okay, so then if I take that L up, I'll have sine theta equals to L sine 120 over 3L. Okay, the L's cancel. Type that into your calculator. Sine theta comes out to be a half. Okay, when you work that out, which implies then, of course, theta is 30 degrees. Okay, so the angle here that I want is going to be 30 degrees. Right, so this angle here is 30 degrees. This will resolve to be 8 cos 30, sorry. And this then will be 8 sine 30. Okay, so of course that will equal then, well, we can work them out later on. But next thing we're going to do, right, because it asks for show that particle A starts to move in a direction which makes an angle of 30 degrees with the line joining A and B. So of course that's 30 degrees. This is 30 degrees, isn't it? So we've shown it. Okay, so I suppose we need to specify here that the angle that we've got here at A, okay, is a result of taking away the 120 degrees we've got here and the 30 here. Okay, so just be clear on that, so we get 30 degrees, and that's direction it's going to be moving at, isn't it? Okay, it's going to go going along there. Find the speed with which each particle begins to move and determine the magnitude of the impulsive tension. So we need the before and after situation now. Okay, so beforehand you've got A isn't moving. B will have that component there, 8 cos 30 and 8 sine 30. Okay, after then, well, of course we've got A will be moving along with that speed, which is we'll call V, and because it'll go along the string, won't it? B will obviously then, as a result of the jerk of the string, the speed's going to change. So we'll have V going that way, okay, and we'll have W then going perpendicular to it. All right. So we look at the rules, conservation of momentum. Okay, so momentum before along the string, we'll have 8 cos 30 times the mass of B. What was the mass of B? 2 kilograms. No, it wasn't. So we'll look 5 kilograms. none there, and then you've got the velocity after them, so it'll be 5 times v, plus then this one, which is the mass was 3, so 3 times v, so you have 8 cos 30, so 8 root 3 upon 2 times 5 equals 8v, okay, so the 8's will cancel, so we have v equals 5 root 3 upon 2, okay. Perpendicular then to the string, I mean, if you might want to put that as a decimal, 4.33 meters per second. If we resolve perpendicular then to the string, you've got beforehand 8 sine 30 equals then 8 sine 30 times, the mass, which is 5, equals then perpendicular string after. Well, all you've got is this, and you have w times 5. Okay, so then w ends up to be, the 5's cancel, it will end up to be 4. Okay, so then we can see what the speed of A is. Speed of A, quite simply, speed of A is just this here, v, we worked out to be, which is 4.33. Speed of B will be Pythagoras with v and w, okay, so it'll be the square root of 4 squared plus 4.33 squared, so you work that out, you get 5.9 meters per second, and then to get the change of momentum, to get the impulse on the string, impulsive tension on string, well, you just look at the change of momentum on A. Let's focus on A, because A is the easy one, isn't it? So you've got your v, which is 4.33 times the mass of A, which was, what was it? Using track here. 3. Take away then 0 times 3, so you work that out and you get 12.99 Newton seconds.